I'm Paul Sonderegger, Senior Data Strategist at Oracle, and welcome to Shining a Light on the Hidden Data Economy. Data is now a kind of capital. And this isn't a metaphor like data is the new oil or data is the new gold. What we're saying with data capital is that data fulfills the literal economic textbook definition of capital. Capital is a produced good as opposed to a natural resource that you dig out of the ground. You have to invest to create a produced good, a capital good. More importantly, though, capital is a necessary input into other goods and services. It's what economists call a factor of production. And if you don't have that factor of production, you can't create the product or service you have in mind. So say you designed a skyscraper, for example, but you lacked the financial capital to pay for its construction. You can't have that skyscraper. Similarly, if you designed a fraud detection algorithm, but you lacked the data to feed it, you can't deliver that service. Data capital is an economic factor of production in digital goods and services. And this makes data capital really important. It also probably makes it really valuable. However, no one can say for sure because no one's figured out exactly how to directly measure the value of data just yet. But researchers at Wharton and Stanford have come up with a broader measure that they call digital capital. The authors of this new paper, including Eric Brynjolfsson, the director of the Stanford Digital Economy Lab, estimate that 25% of a firm's value is digital capital. Now, they define digital capital as factors of production that are, one, complementary to IT assets, but two, are not otherwise recorded on the balance sheet. So what they're talking about here are investments complementary to IT assets like hardware and software that enable those assets to create value for the firm. And so this includes things like investments that are made in, say, organizational changes or process changes that make it possible for technology to create value. Now, the way that they do this involves some very fancy math that I'm not going to go into here, but the essence of it is that the researchers take observable inputs like firm-level data on IT asset expenditures and IT labor, and then infer the portion of a company's market capitalization that can be attributed to their use of digital technology. And what they find is that on average, 25% of a firm's value is digital capital. But this obscures the real story. The real story is the intense concentration of digital capital in the hands of just a few superstar firms. In fact, the researchers found that digital capital is more concentrated than any other asset class. Now, what you see here in this chart is the value of the digital capital owned by the firms that they studied over time, and the firms are broken out into quartiles. And that top dashed line that you see there is the top 25% of firms by market cap. It is the value of their digital capital. And you can see that that value grows and in fact pulls away from the rest of the market over time. So this concentration is intense at the quartile division level, but this chart looks the same again when you divide the terms into deciles, when you divide the firms into deciles. The researchers found that the top 1/10 of firms have the majority of digital capital value, and their advantage over the rest of the firms in the rest of the market grows over time. They also found that digital capital accumulation predicts firm productivity 3 years out. So this large amount of digital capital amassed into the hands of a few firms then gives them ability to become more productive 3 years out. So what does all this mean to you? Well, the real lesson here is that just having technology is not enough. Of course, it is the way that you use digital technology that really matters, the way that you incorporate it into your core operations, your decision processes, your interactions with customers. And to be fair, this is not an earth-shattering revelation. But here's the thing. Most executives still lack a good way of thinking about what to do about this. Most executives still lack a solid framework for connecting competitive strategy to data architecture. And that is what we're going to look at here today. I'm going to help you see the hidden data economy inside your firm. I'm going to help you understand how to bring it into the light and encourage it to grow, to increase your return on data capital. Now, this hidden data economy inside your company has a supply side where applications and sensors and devices originate data in different structures and shapes, and a demand side where analytics and AI and other applications attempt to use the data that originates elsewhere. Now, let me show you what this looks like in a little more detail. For most enterprises, their hidden data economy began as a command data economy. A centralized organization, usually IT, decided, here are the applications we're going to have, here are the business processes they're going to support, here's the data that they're going to produce, and here are the predetermined questions that that data will answer. This centralized command data economy approach was basically standard operating procedure until the early 2000s. However, this led to latent demand, unanswered questions on the business side that gave rise to an informal data economy. And here, departmental IT created their own stocks of data capital. They got their own analytical tools to work on these stocks of data capital. But this was then turbocharged by a diversification of the supply. As company websites, departmental websites, mobile apps, sensors, as they all proliferated, there were new sources of data supply that allowed this informal data economy to create value that the command data economy could not. Now, as time went by, some IT organizations tried to respond by creating places to pool large amounts of diverse data. But this still largely operated as an informal data economy alongside the command one. Meanwhile, on the internet, something completely different happened. A market data economy arose. And the market data economy overturned two critical assumptions at the heart of the command data economy. First, the market data economy completely decentralized both data supply and data demand. The proliferation of websites and internet consumer services and smart devices led to an explosion in available data. And APIs led to a chaotic blossoming of uses of data. The second critical assumption that the market data economy overturned from the command data economy was that it blurred the line between supply and demand, between points of creation and points of use. Because when you take an AI model, like say a recommendation engine, and you inject it into an application, like say an e-commerce site, that AI model's actions then affect the next actions of the user. And then you take observations about that, enriching your supply of data capital, which leads to this data flywheel effect of using data to create data. And that often leads to winner-take-all outcomes. Okay. Why is this important? Why does this matter to you? The reason it matters is because all three of these data economies are likely operating in your firm right now, probably separately. And that leads to dead data capital. Dead data capital are data assets that either go unused or fail to deliver their full option value because they're trapped in silos, or they're too labor intensive to repurpose, or they're undiscoverable. Nobody knows they're there and nobody can even find out they're there. Or maybe the governance is weak and so their allowed uses are unclear. Now, obviously, this is unacceptable. And this is why every company is bent on digital transformation, on trying to create some strategy for how they can create more value from their data assets. But there is a problem. And the problem is that as these companies pursue digital transformation, they face the twin threats of digital transformation. One is loss of competitive advantage from not moving fast enough on the one side. The other is the risk of legal and reputational damage that comes from potentially moving too fast on the other. And every enterprise has to thread this needle over and over and over again as they try to create new ways to bring their hidden data economy into the light, encourage it to grow. So, what do you do? How can you safely grow your digital economy? How can you safely grow this hidden data economy and balance data innovation on the one side with data compliance on the other? Well, to see how to do this, we have to take a big step back to talk about strategy. Because the essential starting point here is a data strategy that reinforces competitive strategy. And to talk about strategy, we turn to the godfather of competitive strategy, Michael Porter at Harvard Business School. Michael Porter defined competitive strategy like this. Competitive strategy is creating unique value in a unique way. It's not enough that your customers can get something from you that they can't get from anyone else. You also have to deliver that value through activities your rivals cannot easily copy. All right, so what does this mean for data strategy? Well, data strategy needs to reinforce your competitive strategy. And so that basically comes down to creating unique data assets, observations that only you have, and then using them in ways to enhance the uniqueness of your firm. Either its differentiation or its superior cost position over rivals, or probably both. But because this is a data strategy, there is one more element that's really crucial, and that is as you plan what kind of data assets you're going to capture and how you're going to use them, you also have to craft ways to protect both the observer, that's you, and the observed, which may include your customers, your employees, or possibly partners. Because every enterprise must balance data innovation on the one side with data compliance on the other, every data strategy must take into account constraints of legislation, regulation, business ethics, and cultural norms as you think through this plan of what data assets to create and what uses to put them to. But what connects competitive strategy with data strategy? How do you tie them together? The answer is to look at the firm's activities. Activities consist of everything, every process, every decision that a firm does or makes. So the way that a company designs its products or services, the way that it distributes them, the way that it sells them, the way that it supports them, all of these things are the activities of the firm. And the way that those activities fit together in a unique activity system is the embodiment of its competitive strategy. So in what is probably Porter's most famous article on competitive strategy in the late 90s entitled, "What is Strategy?" He laid out this theory and analyzed a few firms in order to show their activity systems and the way that those activity systems embodied the competitive strategy of the firm. And so he looked at Southwest, for example. So let's just take a look at the activities that Porter identified that make this unique activity system for Southwest. And we'll just look at the major ones. So he identified that they have limited passenger service, short-haul point-to-point routes between mid-sized cities and secondary airports, very low ticket prices, high aircraft utilization, lean, highly productive ground and gate crews, and frequent, reliable departures. These activities fit together in a unique system that made Southwest's slogan, Southwest, the low-fare airline, more than just a tagline. This activity system made that slogan a unique, defensible, strategic position in a highly competitive industry. All right, so why are we looking at a firm in the late 90s in order to understand modern data strategy today? Here's the reason why. The reason is that in the late 90s, most of these activities were not digitized. And this helps us to see more clearly how to craft a data strategy, because one of the critical skills that you need to develop is how to see the data that isn't there yet. Both the data that is evaporating off of these activities like so much steam because you're not capturing it, and the data that a business process or decision requires in order to be more effective, but for whatever reason, currently lacks. Let me give you an example. Let's say that some ambitious manager at Southwest looks at their 15-minute gate turnaround times and asks, what if we got to 10-minute turnaround times? Can we get to 10-minute turnarounds at the gate if we use a predictive maintenance algorithm for the airplanes? Okay, the idea being that if they could cut their turnaround time by a third, that would make the unique fit of their activity system that much tighter and their strategic position that much more defensible. Okay, could be a good idea, but where will the supply come from for this new demand? Well, they're going to need sensor data from engines and subsystems, for example. But if there are no sensors on that capital equipment, well, then they're going to have to be purchased, installed in order to create this new set of observations, in order to create this new data capital asset. Okay, what else are they going to need? Well, they're also going to need other sources of data like record data from aircraft utilization and repair and maintenance records and information on arrivals and departure times. And all of these individual pieces of data from the supply side, they all have their own supply side shape. And they're going to have to be transformed into the demand side shape in order to feed this new model. But of course, as they do this, they have to think about how to create protections for both the observer and the observed. And so they may need to anonymize or mask employee data that may be in those maintenance records. They're probably also going to have to create some kind of monitoring capability to make sure that the predictive model maintains its power even as the planes themselves age. All right, so this is one example, but the general method is to start on the demand side, to first look for uses of data that will enhance the firm's uniqueness. And so here, focus on activities unique to you. And one of the best ways to do that is to look at linkages among activities, because linkages embody the fit in your activity system. They often embody unique trade-offs that you have made in your business model and execution style in order to create this unique value that your customers can only get from you and deliver it in a way that your rivals cannot easily copy. Also look for opportunities to use data to make data. And one of the most powerful ways to do this is to inject analytics and AI directly into your business processes, where data created elsewhere can now do something active in order to make that process more efficient or to enable decisions that leave the firm better off than you otherwise would be. Then move to the supply side and look for ways to create unique data assets. Again, this means focusing on activities that are unique to you, but also prioritize interactions with customers and with partners, because here you are competing for data with rivals. Any interaction that you conduct with your customers and capture observations from, those are observations that your rivals will never have, and vice versa. And as you think about capturing data from these interactions with customers, for example, or even from your core operational processes, think about capturing more attributes, not just more instances. This is kind of like opening the aperture on your camera for each snapshot you take, taking in more of the scene. And of course, you have to think about creating protections for the observer and the observed. And so here, this will mean gathering consent from the observed. Again, it could be consumers, could be partners, could be employees. You'll need to profile, aggregate, and anonymize this data and install controls that allow you to track and audit how has it been used and where. Now, this is a lot of work. Crafting a data strategy, building an architecture to execute it is a lot of work. And here's where another idea may become very, very useful. Data products. Data products are the building blocks of data strategy. Now, this is not an Oracle idea. Data products, the idea of data products have been around and kind of floating around in the data science community for years. They also figure prominently in the excellent work by Zhamak Dehghani at ThoughtWorks. But this is an Oracle take on this crucial idea. A data product is a discrete set of observations and its complementary code designed to fulfill one or more jobs to be done. It is these aspects, the observations and its complementary code designed for a particular use or uses that elevate a data product above a mere data asset. Now, there are data products on both the supply side and the demand side, and they're a little bit different. So on the supply side, most data products are passive. They're mostly data that is something. For example, data sets in different shapes and structures originated from these applications and sensors and devices. On the supply side, passive data products can also include models that are ready to be used and repurposed. These could be industry models. They could be business process models, workflow models. This could also include libraries, say, of inert algorithms where the structure is known. You've already done that, but it's sitting on the shelf, ready to be pulled off of the shelf and then trained up on a new data set, for example. On the demand side, these are data products that are mostly active, data that does something. And this includes things like analytics, and of course, like reports and dashboards, and of course, AI, like, say, machine learning models that do scoring or categorization or make predictions. This can also include data services that deliver JSON payloads or that allow subscriptions to Kafka topics that handle authorization for access, for example. Now, companies that are embracing this approach of data products, they find that they have a great diversity of them at varying levels of maturity on both the supply side and the demand side. And the challenge is how to simplify the interaction between them. And that is where a new data backbone brings it all together to help a firm create a regulated market data economy. Now, this new backbone uses common data tier technologies so that you can spin up data products on the supply side, can spin up data products on the demand side, and yet have a common, coherent security governance model across them. The essence of this data backbone is that it has to provide a common way of instantiating data products, even though they may use different data models, even though they may use, they may have entirely different workload characteristics, and yet still be able to instantiate data products on the demand side that also have completely different models, completely different workload characteristics, but do this in a way such that data products created in this centralized command economy and this decentralized market economy can interact. And with that combination of flexibility and yet coherent governance and security, bring the informal data economy into the fold. Now, each company's data backbone is going to be different because it has to be tailored to your data strategy, to the operating environments that you're working in. So this data backbone must operate across multiple clouds and on premises. However, there are four principles that guide the way in creating a tailored data backbone for your internal data economy. And those four principles are data liquidity, data productivity, data security, and data governance. Data liquidity is the ease of data reuse and recombination. And one of the main ways that we help companies increase their data liquidity is through Oracle's converged database, because it allows you to create shape-shifting data products. So on the supply side, you ought to be able to write down the data as the application or device or sensor, or whatever it may be, requires. So for example, maybe you want to write it down as a bunch of JSON documents. But then you ought to be able to access it according to the needs of the demand side. So you ought to be able to then access those JSON documents with SQL analytics as if they had been born as tables. And then when another data science team says that they want to access that same data with as if it had been born in a graph, they should be able to do that too without disrupting any of those other operations. Another way that we help firms increase their data liquidity is through Golden Gate. Because Golden Gate provides transactionally consistent data events across a distributed data architecture. This means that you can spin up a data product in, say, one cloud, but then enable its use in another while maintaining transactionally consistent data across that entire span of your data economy. The next big principle here is data productivity. Data productivity is value created as a result of data usage per unit of work, or dollar invested, or resource consumed. And one of the main ways that we help companies increase their data productivity is through adaptive intelligent apps, which let you inject AI models trained on your data directly into your business processes. So for example, in HR, we offer intelligent matching, which algorithmically connects jobs to candidates and then recommends candidates for jobs, and does so directly in the hiring process. Another way that we help firms increase their data productivity is through Oracle Analytics, which uses Oracle Analytics Cloud, which uses augmented AI to automatically derive narratives from analytical dashboards. Data security, of course, is about providing protections against external and internal threats. And we do this through a wide variety of services and offerings, but it includes things like Oracle Cloud Guard, which automatically detects misconfigurations across your Oracle Cloud Infrastructure tenancies. Another way that we improve data security is through services like DataSafe, which automatically profiles data in Oracle databases, both on premises and in the cloud, looking for sensitive data like government identification numbers, for example, or addresses, so that you can better target your compliance efforts. And that brings us to data governance, which is about assurances of data quality, compliance, and ethics. One of the ways that we help companies with their data governance across their internal data economy is through OCI Data Catalog, a metadata management service that harvests metadata from assets all over, from across the enterprise, helping companies keep track of where those data assets are and making them available to data science and analytical teams, for example. Another way that we help companies with their data governance is through very deep capabilities in Oracle's converged database. Take sharding, for example. Sharding splits up a global single database instance into multiple pieces, like shards of a crystal. And when you shard a database by country, that helps you to maintain compliance with data sovereignty laws. And then one last thing, one of the ways that we help companies with data ethics around AI is through incorporating behaviors into these algorithms that monitor for risks. For example, in the intelligent matching I mentioned earlier, we have incorporated behavior that constantly evaluates the performance of that algorithm against fairness metrics to ensure against algorithmic bias. So these are the 4 principles for translating data strategy into data architecture. But you don't have to take our word for it. You can learn from companies already putting these ideas into action at oracle.com/customers, as well as learn about solution patterns that do this as well at docs.oracle.com/solutions. We've covered a lot of ground here today, from data capital through data strategy through data architecture. But here's the one thing that I hope you take away from our time together. Oracle can help you increase your return on data capital. And the reason is that Oracle can help you create this new data backbone that allows you to spin up data products on the supply side and on the demand side with different data models, with different workload requirements, and then reduce the time, cost, and effort to connect them together, whether they originate from your command data economy or whether they originate from your market data economy, and bring that informal data economy into the fold. This is why your data is worth more with Oracle. Thanks very much.